so we're going to get back into integration techniques. We reviewed from Calc 1 kind of 11 rules that are the reverse of differentiation rules, the 11 basic forms that we use over and over. And then we've also got the sum and difference rules and the constant multiple rule that are the reverse of those for derivatives. And then we did U substitution, which was kind of the first new topic in this course. And what was U substitution the reverse of? Do you guys remember? And you can say it out loud or say it in the chat.
Chain rule?
Yeah, so U substitution is the chain rule, or the reverse of the chain rule. So what does that leave that you learn in Calc 1 for derivatives, but we haven't yet reversed in here?
The quotient rule thing?
Yeah, the quotient rule and the product rule. And so we haven't done those yet. It turns out that the quotient rule and the product rule are equivalent to each other, because if you have, so like the product rule is talking about f of x times g of x. If you have that, that's the same thing as f of x over g to the negative 1. Let's not write it that way. Let's write it not g inverse, g of x to the negative 1. And so because of that property, you can rewrite the quotient rule in terms of the product rule and vice versa. So what we're going to do is we're going to reverse the product rule, and integrals that we can do because of that, that's going to actually cover any of them that we could do by reversing the quotient rule. So what we're going to look at is, okay, the product rule from Calc 1 says, okay, the derivative of f of x times g of x is equal to the derivative of f times g plus f times the derivative of g. And so in order to reverse that, what we're actually going to do is take the antiderivative of both sides with respect to x. So if I take the antiderivative of the left side with respect to x, so this is saying the derivative of f times g with respect to x. And then if I take the antiderivative of that with respect to x, I get f times g, because it undoes that. And so then on the right-hand side, we're just going to say, okay, that's equal to the antiderivative of the whole thing. Put bracket in there. Okay, so that's true just by taking the antiderivative of the whole thing. So the left-hand side saying the derivative of this is equal to this, which means that f of x, g of x is equal to the antiderivative of this with respect to x. The sum rule lets you split that up. A little bit neater. All right, and so now we can rearrange this how we want, but I want you to take a second and I want you to solve for this integral. So I want you to rearrange this so that we've solved for the integral on the right. So I want to write, okay, f of x g prime of x is equal to something. Just take a few seconds and write down what you think that's equal to based on what we've got. And if you're wrong, fix it in a minute. Okay, so that's equal to f of x, g of x minus the integral of f prime of x, g of x, dx. Does that make sense? All right, any questions so far? Okay, so now given the substitution that we would do with like u substitution. So given the definitions we used before, I want to make this substitution. So I want to say, okay, u is equal to f of x, and v is equal to g of x. And then if u is f of x, what would du then equal, kind of based on the way we've thought of that before? So what would du equal based on what we did with like integration or u substitution? What would that be?
Would it be f prime of x?
Yeah, it'd be f prime of x times dx. So f prime of x dx. And then dv, same deal. dv would be g prime of x dx. So then, okay, again, take a few seconds and let's rewrite this equation in terms of those symbols. So in terms of u, du, v, and dv. See if you can rewrite that equation in terms of those, and then check with me again in a minute. All right, so the left-hand side is u dv, so the integral of u dv, because f is u, and then g prime with dx is dv, is equal to uv minus, and now we got to rearrange this one a little bit, but v is g of x, and then f prime of x dx is du. And so we have this formula that we get by reversing the product rule. Does everybody follow what happened on each step? It's not necessarily clear why this is important yet. It turns out it ends up letting us do a lot of integrals that we could not do before, but that's not real clear at this stage. Are we clear though how to get this from the product rule? So we're basically, you just take the antiderivative and then you rearrange stuff and you get it to here. Any questions on that? Okay. And like I said, it's not real clear why that's important, but this formula that we've got is called the integration by parts formula. So we call this whoops, no M in integration probably. So integration by parts. And now we're going to see today how to use this formula. But we know now why it's going to work is because it's the reverse of the quotient rule. So I want to go through an example where we use that. And let's do number one. It's going to be the integral of x sine x dx. And so, okay, so integration by parts we will work on kind of as we move along, and especially in tomorrow's lecture. We will work on how to know when to use integration by parts and how to pick everything out. But right now what I want to focus on is just the mechanics of how this works. So given that this is integration by parts, which is not clear yet, but we'll talk more about that. But given that this is integration by parts, what you do is, like when you're doing u sub, you pick u and you find du. That's not what you do with integration by parts. Integration by parts, the problem starts as what's on the left-hand side of this integration by parts formula. So you actually pick u and you pick dv. dv basically will always involve dx, but it could be part of another part of the problem, including dx, or it could just be one dx. U is going to be part of the problem as well. And u times dv is going to equal this entire integral. And so what we're going to do on this problem is we're going to choose for u to equal x. And we're going to choose for dv to equal sine x dx. And those things should be in the problem already. Okay? So we're going to pick for u to equal x, dv to equal sine x dx. And now the idea is if I multiplied those together, I would get back to what I started with. So this is really this integral. Okay, now we're going to go ahead and find the other things. So there's four things going on. There's u, there's du, there's dv, and there's v. So to go from u to du, you take the derivative. So what is the derivative of x, obviously, with respect to x? Just 1, right? And so we get 1 dx for du. But to go from dv to v, you take the antiderivative, okay? So be careful with the signs, but what is the antiderivative of sine? Positive cosine, negative cosine, or something else?
Negative cosine.
Negative cosine. So v is going to be negative cosine x. Is everybody clear what we're doing there? Any questions? Okay, so now, like I said, we pick u and we pick dv, which is why I'm doing these backwards. So dv is on top because that's what we chose. So we pick u, we pick dv, we find du, that's the derivative of u times dx, and we find v, that's the antiderivative of dv with respect to x. Now we plug it into this formula. So what this says is, okay, that integral is equal to u times v. Well, u times v here is negative x cosine x. So u times v is x times negative cosine x. That's negative x cosine x minus the integral of v du. So minus the integral negative cosine x dx. Does that make sense to everybody? Good. Okay, now we're going to take a step to simplify that. So I'm going to go negative x cosine x, and then just pull the negative out. So we get plus the integral of cosine x dx. And now we're not done with this problem, but this integral can be done using techniques we know how to do already. This one's a basic form. What's the antiderivative of cosine x dx?
Sine x plus c.
Yeah, sine x plus c. So we get negative x cosine x plus sine x plus c, and that's the answer. Okay, so at this stage, what I want to focus on is what happens on each step. So we're trying to get good at this process. We'll talk more later about how to pick what u is, how to pick what dv is, and how to know to even do this to begin with. So those are questions that we definitely want to get to, but that's not clear right now. What we want to focus on is, okay, if I tell you what it is and I tell you to do parts, can we just do each step? And so that's what we want to get good at today. Any questions on that, on what's going on each step, or why it's negative, why it's positive? Anything so far? You guys good? Is dv not sine? Yeah, dv it's sine x dx. Is that right? Is that what you're asking? Yeah, so dv is sine x dx, which makes v negative cosine. But then dv is not in this part of the formula. Does that answer the question that's in chat? Sorry. Okay, cool. Other questions? Okay, let's go through another one. So I'm going to write the formula down over here. So u equals x dv. Oh, I'm sorry. That's not the formula I wanted to write. I want to write the integral of u dv is equal to uv minus the integral of v du. All right, and so on this problem, you should set it up where u is x and dv is e to the x dx. And I want you guys to try this. So take a minute, see if you can get it. Follow the steps from the last one as close as you can, and then check it with me here in just a minute. All right, so if we pick u to equal x, du should equal 1 dx again. V is the antiderivative of e to the x dx, so v is e to the x. So we get uv, that's x e to the x, minus the integral of v du, so we get e to the x dx. And now that's x e to the x minus e to the x plus c. And that's the answer. Does everybody follow, or is that what we're getting? Is getting that? Okay, so good. So we're going to definitely get into harder problems, and we're going to talk more about how to choose what everything is on these problems. But one thing that is important to be able to do is if I choose for u to equal cosine of 3x on a different problem, then to go from u to du, you take the derivative of that. And so there could be a lot of these where there will be a lot of these where there's a very quick chain rule that we want to just get used to doing again. So if we take the derivative of cosine without 3x in there, what would that be? So what's the derivative of cosine? Negative sine, right? And so, okay, this is negative sine of 3x, but then times 3 because of the chain rule. Does that make sense to everybody? So real fast, if u is cosine of 3x, du is negative 3 sine of 3x. If we have a different problem where u is e to the negative 7x, du is negative 7 e to the negative 7x dx on both of these because of the chain rule. Does that make sense to everybody? Okay, now going backward, we want to be able to, if possible, do that in your head as well. If you can't, that's fine. You can write it out every time. But if you were to do a problem where dv is cosine of 3x, technically what happens is to go from dv to v, you do the antiderivative. So you do the antiderivative of cosine 3x dx, and that's technically a u substitution problem. But u is 3x, du is just 3 dx, so you multiply inside by 3 and outside by 1/3. So we get 1/3 integral cosine u du, which is 1/3 sine u plus c, and that's 1/3 sine of 3x plus c, which makes v 1/3 sine of 3x. So what I'm trying to say is that you can write this out every time if you want to go from dv to v. But if you can do ones like this in your head, and ones like this, what I mean is it's a quick u substitution where du is just a constant times dx. If you can do that in your head, I think it's going to be easier for you. And so if you can get in the habit of doing that, let's do. So the way I would think of this is think, okay, if this was just cosine x, the antiderivative would be positive sine. Because of the 3x, I need a 3 here and a 1/3 outside. So I'm going to get 1/3 sine of 3x. The 3 is part of the du. If I did another one where dv is like e to the 6x, Colin, I'll get to your question. That's a good question, but we'll get to that question in a minute. So if dv is e to the 6x, v is going to be 1/6 e to the 6x. 1/6 e to the 6x. Does that make sense to everybody? Clear? Any questions on that? And so then if we had on a different set, if u was sine of 3x over 4, or if dv was sine of 3x over 4 dx, du here, derivative of sine is positive cosine, and then we multiply by 3/4 because of the chain rule. The antiderivative of sine is negative cosine, and we multiply by the reciprocal because of the u substitution. So we get negative 4/3 cosine of 3x over 4 as v. And like I said, if you can do that in your head, I think it will make it easier for you. You definitely don't have to. If it's going to mess you up to do it in your head, then you do the u sub on the side like I did here. But within integration by parts, you want to just go from dv to v, and then that will be it. Does that make sense? Any questions on that? If you guys have your mics on, if you can mute them. I can mute everybody here in a sec, I guess. So anyway, if you do have a question, unmute yourself and ask. But all right, so the question in the chat is, why don't you have to put the plus c at the end for v? If we have time, Colin, we will work one where we go through. It turns out you can, and it doesn't matter. But if we have time, we'll work one maybe tomorrow toward the end of class where that's the case and kind of see that. But it turns out it does not matter. But basically, because if you do it, it doesn't affect it. Okay, so we can look at one if we have time. All right, any other questions so far? Okay. All right, so let's go through another problem. Let's go through the integral of x sine of 6x. And I want you guys to try that and start it by letting u equal x and let dv equal sine of 6x dx. Okay, so try it and then fix it in a minute if you're wrong. So I'm actually going to start working on the screen. If you're good, keep working. I'm not going to talk through the steps right now and just put the answer up with the work, but check it kind of as you go. Okay, so we should be getting that. Is that what we're getting? Questions on that? Okay, so kind of look at what you're doing versus what I'm doing. These can get very tedious. So you might have to deal with a lot of fractions and things like that. So if your first step looks like my first step does, that's completely fine. I'm going to normally probably skip this first step. But regardless of what your first step looks like, you should get to a step where it's neatened up before you try to deal with this new integral. So like, you know, the UV part doesn't matter a whole lot because we're kind of done dealing with that. So when we've got U times V, if you put it that way, that's fine. This is the standard way to write it. But when you're doing the VDU part, you definitely want to take a step to pull the constant out, deal with the negative signs and determine at that point whether it's positive or negative, and get it so that this is either a basic form or, like in this case, it's a very quick U substitution that we could again do in our head, or you can write it out where U is 6x. But the reason I'm getting 1 over 36 is because of the additional 1/6 I'm going to get by doing the antiderivative of cosine 6x. But anyway, the point is, let's definitely take a step to get it to look like this before advancing any further in the problem. Any questions so far? You guys good? Okay, so we're going to do another one, and all right, so based on what we've done so far, maybe what should we let U equal and what should we let dV equal when we're doing this? What do you guys think? So what would U equal? X squared or e to the 3x? Or something else? Yeah, x squared. So, all right, somebody's saying that in the chat. U equals x squared. And then that's going to leave dV to equal e to the negative 3x dx. So if we do that, then du is 2x dx. It's the derivative of u. And v is the antiderivative of e to the negative 3x, which is negative 1/3 e to the negative 3x, because again, that's a quick u substitution where u would equal negative 3x. Any questions on that so far? Okay, so now you can write a step that looks like this, but I'm going to try to, what I want you to try to get in the habit of doing is neatening up as you go. So when we start writing it, we're going to start with uv. And so go ahead and figure out what that is when you multiply those together. So u times v is negative 1/3 x squared e to the negative 3x. So that's what we get when we rearrange u times v. If you wanted to move the e to the negative 3x to the bottom, you could. But given the way the problem was written, there's definitely no need to do that. But it is a good idea to neaten up as you go. And now, if I do v times du, which is what we get in that integral, so let me write that formula down again real fast. So it's, remember, it's uv minus the integral of v du. So if I do v times du, what's the coefficient when I multiply those together? So after I multiply this times this, what's the coefficient going to be? What do you guys think?
Negative 2/3.
Negative 2/3. And we're going to pull that out. So because it's minus, we're going to go ahead and make it plus 2/3. And then, okay, so that's dealing with the coefficients. Inside, we're going to have e to the negative 3x, x, and dx. Well, the normal way to write that would be to put the x first, the e to the negative 3x next, and the dx last. And so, like I said, you don't have to simplify immediately, but it is a really good idea to simplify before you go on, because it's usually easier from this neatened up form to figure out what to do next. Okay, any questions on how to get to here? We're all good? Okay, so now if we look at this as a brand new problem, so the way integration by parts works is we've got this uv out here, but we don't really care much about that. Like, that's definitely part of the answer, but we're done dealing with it as far as an integral. What happens is we have this new integral to deal with. And so the new integral could be a basic form from like Calc 1. It could be U substitution, or it could be something more complicated than that. In this case, if I just gave you this problem and you ignored everything else, what would you do to do that problem? What do you guys think? U sub's a good try. The problem is this X out here. I think with U sub, that's not going to work. What else?
Would it have to be another one of these integrations?
Yeah, so it's this problem is just like this problem with a -3 there, right? And so we're going to do integration by parts again on this. So I'm going to do that in a different color just to make it more clear. But we're going to let U equal X, and we're going to let dV equal e to the -3x dx, and we're going to do this again. So du is 1 dx, and v is -1/3 e to the -3x when we set it up for this new integral. Does that make sense to everybody? And now the idea is we're going to have this -1/3 x squared e to the -3x. That's just going to carry down. And then plus 2/3. And then we're going to put brackets. And we're going to put the entire integration by parts formula in the brackets. That doesn't look very good, so let's do that again. But we've got 2/3 times. Now, it's going to be uv. So u times v for this is -1/3 x e to the -3x, and then minus v times du. Well, the coefficient on v times du is -1/3, so it's going to end up being +1/3 integral e to the -3x dx, but all of that's in brackets. Does that make sense to everybody? So the integral up here gets replaced. So that's the integral of u dv for the integration by parts formula. That gets replaced with all the stuff in brackets, which is what this formula is. That makes sense? Okay, now we're going to take a step to distribute the 2/3. As you can kind of see already, the fractions and the negative signs can get real tedious on these, so you have to be real careful with them. So you distribute the 2/3, and we're going to get -2/9 x e to the -3x, and then plus 2/9 integral e to the -3x dx. We're not quite done, but any questions to there? Yes, good. Okay, now this last integral is technically a quick U sub, but it's one of the ones where I'd like us to be able to do it in our head. And so if we do it, everything here carries down. So we get -1/3 x squared e to the -3x minus 2/9 x e to the -3x plus, and actually ends up being minus, but it's 2/9 times -1/3 because of this quick U sub. So U would be -3x, du is -3, so we have a -3 inside, a -1/3 outside. That's going to make that -2/27 e to the -3x plus c. Okay, any questions on that at all? Please ask at this point if you guys have anything. Is that making sense to everybody? Okay. Okay, so I'm going to give you a minute to try this next problem, but I want you to try to work it all the way through without me. So I'm going to give you maybe 2 minutes on this. and work it. Be real careful with the negatives and the brackets and the parentheses and the fractions. But try it. We'll give you a couple of minutes and then we'll work it together after that. Okay, so on this problem, to start out, we should be doing what I've got on the screen. So u should be x squared, dv should be sine of 4x dx. That makes du 2x dx, and v is negative 1/4 cosine of 4x. uv is then negative 1/4 x squared cosine 4x. And if it doesn't look like that to begin with, that's okay. Take an extra step and get to there. And then v du, negative 1/4 times 2 is positive 2/4, which is positive 1/2. So the coefficient ends up being, I'm sorry, negative 1/4 times 2 is negative 2/4, which is negative 1/2. But then when you pull it out, it's minus negative 1/2, so it's plus. And then you get x cosine 4x dx inside the integral. Not done for sure, but is everybody good to there? Any questions to there? And again, let me write, well, there's the formula up there, but let me write it on the screen just so we've got it. So uv minus the integral of v du. As you do more of these, you're going to memorize that pretty easily, but that's the formula. So, okay, so now we're going to do it again. We'll go ahead and do it in red. So u is x this time. dv is cosine 4x dx. That makes du 1 dx. And v is 1/4 sine of 4x. So, okay, so everything carries down. We get the negative 1/4 x squared cosine 4x, so all that carries down, and then plus 1/2 times a bunch of stuff. And so the integration by parts formula now is uv, that's 1/4 x sine of 4x minus, and then v du, we're going to pull the 1/4 out, and then the integral of sine of 4x dx, and all of that's in those brackets. You want to take a step to distribute that 1/2, so we're going to get negative 1/4 x squared cosine of 4x, and then plus 1/8 x sine of 4x, and then minus 1/8 integral sine of 4x dx. That gets us negative 1/4 x squared cosine of 4x plus 1/8 x sine of 4x. And now the integral of sine 4x is negative cosine, but you get a 1/4 because of the u sub. So negative 1/4 times 1/8 is positive 1/32 cosine of 4x plus c, and that last line is the answer. Questions on that? Did we get that? How many of us got that? All right. Some in chat. Okay, good. Good. How many of us were close, but maybe off by a negative sign somewhere or dropped a fraction somewhere? Okay. So yeah, that's, as you can see on this, it very quickly can get real complicated with the fractions, which is why I'm trying to make such a big deal of, hey, rearrange it so it's in like the nice order, and then like take a step to distribute that 1/2. It's just very, very easy to drop a negative sign or mismultiply a fraction or something like that. So you have a lot of fractions typically when you get these longer problems. Sine and cosine, sometimes you're taking the derivative, sometimes you're taking the antiderivative. So it's easy to drop a negative sign with those. So you just have to be real, real meticulous with it. I think the process isn't terrible, but it's something you definitely need to practice. Now, we have a lot of time left today, but before we go into more complicated examples, we need to get good at this process. So you need to be able to do this. And then what we're going to do tomorrow is we're going to get into problems where, okay, we want to know why is this part, and then why are there other problems like this that are u substitution? And then once you figure out that it's parts, what's a good way to know what u is and what dv is, and why don't you flip it? Why don't you do it the other way? It's definitely not always in order. And there's not good answers to those questions. So like, it's just like u sub, like, you know, most of the time this is probably what works and this is what we can think through, but there are definitely exceptions to everything. So we're going to work on strategies to figure that out. We're going to see some other integrals where this can work. It doesn't have to look like these problems, but what I want you to focus on tonight, if you have time, please try to do the homework that's online called, it's on WebAssign again. So it's integration by parts 1. And I think there's just 8 or 9 problems. There's just like 8 or 9 problems on that sheet, and they're a lot like what we're doing today. In fact, some of them might be exact repeats, but take the time to really, really get those because these do get harder, but the way they get harder isn't to become more meticulous like this. It's not like, okay, now we have 6 fractions. Like, I mean, I guess that can happen, but that's not technically what gets harder. What gets harder is, okay, how do I know when to do parts? What do I pick for u and dv? What happens if this just keeps going over and over and over forever? And so we're going to look at all that stuff tomorrow, but we just got to be really, really comfortable with using this and just doing these problems. So the ones on tonight on integration by parts 1, 8 or 9 problems that are almost identical to today's class, but let's get good at that process and then we'll talk more about that tomorrow.